Level 3.2 notes and practice, and hint, it's a big hint. Draw a picture first. And that's what you're going to see me do as we work through our examples here on page 24. First example, point N is on line segment MO. Given MN equals 2x, NO equals x minus 2, and MO equals 2x plus 9, determine the length of MN. So there's a lot of information there that really kind of gets jumbled together unless we have a good picture. And then on top of that, let's try to label our picture. So as we draw this in, it says that point N is on line segment MO. So I'm going to start with MO, and then I'm going to put point N on here. Nothing's drawn to scale here. It doesn't mean, it looks like N is in the middle of my segment, but that doesn't necessarily mean that that is true. But now that we have something, then look at the next statement. Given that MN is 2x and NO is x minus 2, and then it tells us also that the entire length of our segment is 2x plus 9. And we're going to determine the numerical length of MN. Well, in order to do that, we need to figure out what x equals. So we're going to start with 2x, and we're going to add that to x minus 2. That's the segment addition. And when we add that, we're going to get the entire length of our segment, which is 2x plus 9. Remember that the number, or the coefficient in front of the x, is 1, because we're going to combine like terms over here, and we get 3x minus 2 equals 2x plus 9. Solve this the way your Algebra 1 teacher taught you. I will move my letter to the left. We get x minus 2 equals 9. And then we're going to add 2 to both sides. And when we do, we end up with x equals 11. Well, really what the question is asking us is we want to know, well, how long is our segment MN? And if we look back here, MN is 2x. And we're going to take this value of 11 and we're going to put it in for x. So this is going to be 2 times 11. So our numerical length for MN is 22. Let's try example number 2. Point F is on line segment EG. Given FG equals 5x plus 1, EG equals 5x plus 7, and EF equals 2x minus 2, determine the numerical length of EF. Start by drawing a picture. EG, and then point F is on that segment. Again, not drawn to scale, but what we know is that FG is 5x plus 1. EG, which is the entire length, EG is 5x plus 7, and EF is 2x minus 2. And what we're going to do is we're going to use our segment addition again. 2x minus 2 plus 5x plus 1 equals the entire length of that segment of 5x plus 7. Combine like terms, 2x plus 5x is 7x, minus 2 plus 1 is minus 1, equals 5x plus 7. Let's subtract 5x from both sides, and we get 2x minus 1 equals 7. We can add 1 to both sides, and then we end up with 2x equals 8, and divide both sides by 2. So we end up with x equals 4. Sorry, I really had to use my space there. But what we're really trying to look at is the length of EF. Well, EF is 2x minus 2. And we're going to take our answer here of 4. And we're going to put it back in for x. So this is going to be 2 times 4 minus 2, which is 8 minus 2. So our numerical length of EF equals 6.